Now I'm going to cover the test case user that I worked with their data and my analysis stream. So I just want to show some results of what I was able to do. So in that first phase of modeling, so this is using a tree-based model, I was able to, this is the variable importance for the different variables I used in predicting average weekly heart rate. So all these were kind of aggregated by week. And the takeaways here are, so this is kind of the general profile of this user's information. And the major takeaways are that average time that the user woke up was the most important variable in their kind of profile and how sleep and activity related to resting heart rate. Second most important variable for this particular user was average number of calories burned when heart rate was within the fat burning range. And the third most important was average number of deep sleep cycles that they experienced each night. And then after that, there was a big drop off for the other variables. So that was my first phase of modeling. Second phase. So this is where it got more complex. So again, I use linear models for the weekly analyses. So they can't be directly compared with that for the column for the overall weekly because they weren't determined in the same way. All my data was scaled. So you can kind of think of these in a similar way where the absolute value of those values in the rightmost columns, those two columns where the boxes are all around, the absolute value of those represents the magnitude of their influence, and then the sign, so positive or negative, represents the relationship between resting heart rate. So what we learned from this is, so first in terms of their best week, so this is the week with the lowest heart rate. All the most important variables are related to sleep. So there was something that they were doing with their sleep patterns and habits that week that were very influential in creating that lowest resting heart rate week, which is helpful to know moving forward. Now we compare that with the most recent week. We kind of have a mix of sleep and activity patterns and habits that end up being influential in determining resting heart rate fluctuations. Specifically, REM sleep is associated with lower heart rate during their best week, but it's actually associated with higher resting heart rate in their most recent week. So it becomes a positive relationship in the most recent week, whereas a negative relationship during their best week. Some other changes were that physical activity played a much bigger role in reducing resting heart rate in the most recent week. So kind of the major takeaway from all this is that sleep habits during this most recent week were not as helpful in reducing resting heart rate. So the feedback that I would give the user kind of going into the upcoming week would be to encourage them to focus on sleep for the upcoming week and trying to get better sleep habits and things around sleep is what they should focus on for the upcoming week. And that is the presentation of my slides. I'm going to get into the code now. So let me exit this. Okay, so I'm skipping to the analysis step of my code. I do want to show that I have all my steps outlined for working with HTTP and working with an API and all that. So all that information is there if you want to use it. This was all the code that I used to do the pull requests for data and do the authorization. So the only difference is if you were doing something like this, you'd have to change the authorization to be your account or what you're trying to do. But all the steps are there outlined for you to provide guidance. I'm not going to focus on that as much. I'm going to focus on the analysis part. And all the data that I used for the analysis that I ended up pulling is going to be included in my submission material. So you can run this all on that data and it will work. So I created first, to access a specific person's data, I pull their user ID. I have a spreadsheet that is also included in my submission materials that this is able to interface with to pull that information. And then it pulls the data from each of those two streams, which is kept separately. And then I combine that data. Here, instead of creating a schema ahead of time, I end up just recasting all my variables so they're all in the proper format. And I made it after joining, so each row represents a single date, a single day of data for this particular user. I eliminated I eliminate any rows with any null values or empty cells, and that only ended up being like 25 rows, so not that much, but that helped with my analysis later on, where instead of deciding to impute anything, there weren't that many, so I just decided to omit them. I did a lot of date calculations to be able to work with this, so I'm not going to go extensively into this, but if you're interested in using Spark's kind of time functionalities, functions, these can be helpful. So I went through that. I split my data. I'm not going to go through all of this, but ultimately I'm going to get to the methods. I ran a random forest on a training set. And as you can see here, it did not perform well on my validation set, which got me thinking there might be some issues here. So then I took a next step of running another random forest, but this time I ran it on all of my my daily data. Instead of doing train and validation, I kind of wanted to see how well it did in creating this profile. I wasn't worried as much about overfitting. I wanted to actually potentially overfit to create the most accurate profile of this user's data. So I ran a random forest with parameter tuning to try to see, is random forest a good method for creating that profile? And as you can see here, it is not. So it only was able to describe almost 8% of the actual variation in resting heart rate. So that got me thinking that there was probably too much noise in the daily data that was causing issues. So I thought of two things. One, I would switch to doing a weekly aggregation, as well as I switched my method from random forest to gradient boosted tree regression, mainly because gradient boosted trees can have a tendency to overfit more, which again, I actually kind of wanted in this case. I was not, using a model on some data on a completely different data set. I'm trying to create the most accurate and specific profile of this person based on all their data available. So I'm okay with overfitting. So that's what I did here. I did some reloading of data and setting up schemas again. But here I did a re-aggregation, and again, based on a time function, this was really helpful, where I created aggregates based on week intervals starting every Sunday. So that was kind of neat. And I made those and then I grouped by that to create weekly aggregates. I had to go through the whole process of creating my feature vectors all over again, because now I had a new set of data. And then here I used parameter tuning, hyperparameter tuning with a gradient boosting tree to see how well that did with creating a profile of this data. And as you can see here at the bottom, it was able to predict 70% of the variation in my outcome variable. So much better once I switched to weekly aggregate and gradient boosted tree. So that was my phase 1 model. I left it at that. And I was able to pull the variable importance here, which I showed in my slides. Then I have a second phase of model.